Applications of exponential functions. And we're doing a money one, the amount we're going to have when we put money in an interest-bearing account. Okay, so that's what we're going for. If $1,000 is put in an account that yields 5% interest yearly, how much money will be in the account 10 years later? When will there be $10,000 in the account? It's definitely exponential growth because we're putting the money in an account. It yields interest, it adds back in, so we're going forward, upward, so it's growth. Let the function, let's just call it A of t for the amount in the account at time t years. Now we have this formula from before. Growth rate is the growth factor minus 1. But that's algebraically the same as saying the growth factor is 1 plus the growth rate. And you can see that by just adding 1 to both sides, and you'll have growth factor equals 1 plus growth rate, which is this. So now we have all we need. Here's our function name. A of t is $1,000 initially. That's what they put in. And the growth factor is 1 plus the growth rate, and which is 5%. 5%. So that equals 1,000, 1.05 when you add them together. And this looks really, this part right here really looks like the compounding interest formula, but when there's only one compounding period per year. Okay. After 10 years, it asks for what the amount would be, so you put that in the function, work the calculator, and you get about this amount of money, $16.28.89. When will there be $10,000 in the account? So here's your function. There's a formula. So we want the time when there's going to be $10,000 in there. So we'll be able to do that later with logarithms. But right now, we're going to graph it. Here's your function. We want to know when that's going to be 10,000. So when does it intersect the $10,000 line? This is the window that had to be used. We're trying to intersect with a y value of 10,000. So our y max has to be at least 10,000. That's why I put this. Then I just tried different x values until I saw the graph. So here's the function, and here's the $10,000 line, and they intersect, and we used second calc intersect to find the intersection point right there, and then we just read off the 47.19. So about 47 years it would take for the amount to reach $10,000 at that interest rate. There's where the 47 comes from.